Okay, we're gonna rectify everything that was got lost and confused in the last one, and we're gonna try to do it quickly, and that's probably gonna make it difficult. So we have our laser. We're firing 1 photon at a time. We're gonna fire 100 photons, easy, 100 photons. We're not even gonna look at waves anymore. We're just gonna debunk this with photons, with particles, with Einstein's genius. We fire 100 photons, one after another. We have 2 detectors here. 2 detectors, okay? We have a 50-50 split here to reflected and transmitted photons. Our first one, let's say, gets reflected. Boom, hits a piece of silver. Boom, hits another piece of silver. This one's 100% silver, this mirror. Boom, hits a second piece of silver. And who knows what this silver is doing to our photon? Who knows? Who knows besides the fact that it might have smacked an electron out of it, out of the mirror, and produced a current? Who knows? Technically, it must have smacked an electron out of it if it had enough energy. Anyway, I digress and we continue. It reflects off the mirror. Boom. Now let's say for argument's sake, we were using a 50-50 split. And I'm going to get the proper equation because we really need it this time. Oh, are we looking at my designs? A little bit. I got secret designs. Sacred, top sacred. Okay, wait. N 1 minus cos theta over 2 is our distribution. N or 1 plus cos theta. And I don't even know if I can buy these anymore. I don't even know. I did buy the books, so why not? We'll use them. And if we have any sort of completeness in our correction, these are gonna actually work in our favor. I believe that. We'll cover all the ground and we'll debunk it entirely. Okay. Reflected, hits another bullshit beam splitter. This time we're going reflected. So let's just say case 1, reflected, and ain't that something? They're both transmitted on this side. What are you talking? Are you kidding me? No, it doesn't. Whoops, my. Sometimes I trip, eh? I just one little mistake and you can really get lost. So let's do it properly, like this. Reflected. We have 3 reflections. This is also 50-50 splitter. We have 3 reflected. We have also reflected the first beam splitter, reflected the second beam splitter, and then transmitted the last beam splitter. These are 2 different sample sets, I guess you call them. I can't remember what the exact name. Then we have transmitted, another a reflection, and I believe this reflection is actually gonna have some weight on the outcome. I don't think that's negligible. The fact that you hit a piece of silver here and transmitted through a medium there. I even think refraction plays a role in this. And we're not even looking at refraction to prove. It's just not even a complete experiment and a disaster to me. Utterly devastating. This is a $200 book at least, and they ripped me off. But at least I see the truth. At least I can see the bullshit. I digress and we continue. So we have transmitted, reflected, and we're gonna say this is we'll just keep with what we start with, and transmitted. And then lastly we have transmitted, and we can't deny that the second stage is a reflection on the mirror. However, the last time we can say it's reflected. Now, what we saw in the graph was like this. We had it like this, and I'll just do it properly. And there's 100 and over 2. This is n over 2. This is n equals 1, basically, and n equals 1. So let's just say n1 and n2. This is how we do it. This is how we do it. And this is pi. This is pi over, I have to look at the graph. I want to get it. I keep saying that. 1 second. We're going to really blast this out of the water. So what they have N2 and started at the top and N1 started at the bottom. Every 90 degrees. Okay, fine. Why not? Every 90 degrees we have We observe, and this was my main mistake. I do get confused sometimes. I'm not perfect. Nobody is. So bear with me. If you watch that, I'm sure you still got volumes of information from it. Because there's no joke. You can't mess it up when you're dealing with the facts. Some of them are gonna get, and we'll just remove the bad facts and we'll keep the good ones at the end. That's the way I do things. It is the way. Okay, the way forward. So every 90 degrees. So we have pi over, what did you say? What is pi? Pi is 180 degrees. Pi over 2. Over 2. And pi over 2. I'm not gonna do degrees because it's a waste of my time. Not really, but for simplicity, at least I have a chance of memorizing these cos functions with pi's, because I don't remember anything at all about degrees and how to plug them into a calculator. I don't have one, just the one upstairs in my brain. Okay. So what do we observe in the N1 case? This is N. We call this N1 here, and this is N2 over here. I hope you see that. You have a full page, I hope. Okay. So let's just make sure we're complete. We have continuity. So we say the D2 over here, N plus cos. So let's just check our result. N plus cos of pi. What's cos of pi is 1. So we have 2 over 2 is 1. We'll have 1 for N2. So these are backwards. I did them backwards again. Damn it, I always do mess something up. So let's just say N is 1. We could just switch these. Why not? For the sake of this, what does it matter? I'm going to just make sure it's exactly how they debunk themselves. I'm going to see if it's exactly how they debunk their own experiment. Just give me a second. I have to check. D1, D2, okay. How these guys debunk themselves like a joke. N2 ended here. And N1 ended here. And 2 in the subscript is going to match with our detectors, obviously. I'm going with that assumption anyway. I'm not going to play around and waste my time. Just read what's in front of me. I just open my eyes and look. Okay, so N1, we started, and the idea is we can control the phase angle. And they're basically 180 degrees out of phase. They're saying this is going to demonstrate that what happens when the two beams the mediums are angled so that they're 180 degrees out of phase. So I don't know what that looks like, but I guess if you want an even phase shift, you're gonna have to change the length evenly on both arms. We're gonna make that assumption, and you can prove me wrong. I don't think I'm wrong. You have to make that argument. I'm not gonna waste my time. And it's not a waste of time, but for me necessarily, and it might be interesting. But I have to look at more important things right now. I have enough on my plate. N1 starts 180 degrees out of phase. All right. What we basically have is the negative cos is a sine. Basically, that's this one. Right. So N1, D1. Okay, so we have continuity. All right. N1 equals 1. So we fire one photon, and let's say we wanted to land on N1. We just wanted to, because we're sneaky and we're making this up. So we fire one, and we notice when the ratio between these two arms is not even, and it said only produces a pi over 2 phase shift, we get half the results. The statistics say we get half our results on this one and this one. And if you plug it in that equation, it's pretty obvious. It adds up to 0.5 and 0.5. So let's look at the first one. If it reflects, we have a 25% chance on each outcome. Basically, that's probability for you, as I understand it. Which basically means we'll detect 50% on the initial transmitted on this. Now we have to follow the path. It's important. It's not like we can just ignore the path of the photon. I'm not even gonna say the wave. It's such a disgrace. The path of the photon. So we transmit it, bing. It transmits through the transparent medium. there's a reflection, and I can't help but think that's significant. I mean, even if you were dealing with phases, I hope you realize, and I hope this accounts for the fact that every time you mirror light, it inverts the phase. I hope that's accounted for here. And if they didn't, like, honest to goodness, what are these guys doing? They really didn't know. They really didn't know anything. They really didn't know anything, I don't think. Like, it's so obvious. Okay, let's continue. Transmit, reflect, and let's say transmit, reflect, transmit. We got D1. So we can see D1 has at this point has a 50% chance it did that. Right? Technically it says you had, by the time it hits, there's a 50% chance it'll do here, and then by here it gets actually different. This one actually had this transmit weight actually had a 25% chance of going this way at pi over 2 phase shift, at 25% chance going this way. And we're gonna have to redraw this apparatus every time because I can't imagine it being a perfect square to make this work. Okay. Also, there was also a 50% chance it would be reflected. So we have 50 of our 100 photons going this way, 50 going this way, 50 going this way, 25 going this way, 25 this. Now from the reflected wave, we have 25 going this way and 25 going this way. And we did the experiment 100 times. We saw this. It was obvious. 50% of the detections, the hits, the clicks, whatever, landed on D1 or D2, not both. Well, both in the sense that they're both getting hit, but half the time they're getting hit here and half the time they're getting hit here. Okay, right. That's fine with me. I'm gonna keep this page ripped for myself. Now we want a different scenario. We want something else. We want to demonstrate D1, D2, and that's at pi. Sorry, that wasn't there. Let me just clarify it. This example was taking place at a pi phase shift. Let's see what happens at pi over 2 phase shift. All right. And what I think D1 is going to equal N 1 minus cos theta. And D2 is going to be N over 2, 1 plus cos theta over 2. And I can't even remember. Is it even half? I mean, this tells me it's half. This tells me, regardless, it's going to be N over 2 at pi over 2. So that means pi over 2 must be 0.5. I'm just going to assume, you check. And it's simple. I don't have a calculator, so I'm just going to pull it out of memory and what the graph says. So now we have a different thing. We have 0.5 over 2, 0.5 over 2, and we have 1.5 over 2. So now we have a 25% and a 75%. Let's look at our beam splitter idea again. I don't know. It's going to be something like that, I believe. Anyway, I might have the orientation wrong. There's a laser shooting here. We had to change the apparatus because you have to change the length in order to mess with the phase, basically, or the medium, and that's just going to demonstrate that we've shifted the phase. So boom. Make sure you get this right. This way. So the other one was kind of incorrect, but we figured it out anyway. And this is the odd one. Oh, they're like that. Let me see how they drew. Yeah, the same way. It's pretty obvious. Look, they even gave it to you in a weird angle so you couldn't really wrap your head around it. I can't stand that. Now we'll just say this. It's just all deceiving. Deceit. You can't find the truth because we don't know it. And this is our detector, and this is our detector. Right? And this is the path, and this is the path, and this is the path of the photon, not the wave. Derp. This one's going to be reflected that way. This one will reflect that way for some. If it indeed splits. If it indeed splits, we're doing 50 of them and 50 of them. We're just going to look at the outcome. Does it ever get to zero? Yeah, they do get to zero. And that's a weird thing. That's a weird thing that sometimes we don't witness any detection, even though they're 50-50 split. That's the weird thing. And that's where I'm getting stumped right now. They actually don't detect any on one of the detectors, apparently. And then, but we're going to look at that. We're going to see if something's going on here. When they're 180 degrees out of phase, we don't detect them. When they're pi over 2 out of pi, actually, no, that was, I did this all wrong. I keep messing it up. So brutally. Wasn't it pi? Wait a second, we did pi. Look at that. Did you see that? Was that me? Something happened here. Why isn't this making sense? This is the graph they gave me, by the way. I didn't draw this. I didn't do the experiment. This is the one they gave me. And these equations. And I'm looking at them right now. And those are correct. Cos of pi is 1. It's got to be. And 0 is 1. Right? Cos of 0 is 1. Cos of pi is 0. Is 0. Or minus 1. Minus 1, sorry. Minus 1. Sine. What are we doing here? Sine is... For this one, we say this is 0. So cos pi is... What's cos of pi? Cos starts... I need to look at that. Shoot, man. What am I doing? What you doing, bro? You should do your homework. That's what you should do. I'm just going to pause this and just do a quick search, and then we'll come back.